morning, good afternoon, good evening, depending on where you are from the world. We're gonna wait a couple more minutes, just make sure everybody has time to join, and we'll start. All right, it's been 2 minutes. We're gonna start. So welcome everyone. I'm Nicolas Loof. I'm an informatics solution leader at BDB Informatic, aka FlowJo. I put my email address here on the slide. Don't hesitate to reach out to me if you have any questions. And today we're gonna talk about the BDRC and FlowJo v10. So usually when I go train on a different site or when I meet a customer at conferences, people tell me that for Cytometry data analysis is hard. And usually the main reason they think that is because they want to know how to normalize the data. They think panel design is hard, the spreading, they don't really understand the concept, sample to sample variability, they have issue with that. A lot of question about composition, etc., etc. So here I put the main topics that people have a difficulty with. We're gonna focus a little bit more on the gray one, which are the panel design is hard, annotation, re-annotation, and the data too big, and issue with the data management. And to solve those issues, you can use the BD Research Cloud. Into FlowJo, you can use the same credential. If you don't, just go on our website, bdresearchcloud.com, click on the create account, and just put a new username and password, and you will have access to BD Research Cloud. BD Research Cloud, what is it? It is an ecosystem for flow cytometry experiment. And the idea behind that ecosystem is to increase collaboration, share data more easily, better organize your lab and data, so for your storage, and hopefully grow your lab to its full potential. So as you can see in the window, which is the welcome window on BD Research Cloud, you have many different topics. You have panel, experiment, workflow, data, cytometry, reagent, population, group and project, and user. And we're gonna go in detail in each one of them in the next few slides. So a panel is to design your flow cytometry experiment panel. So it's cytometer specific, so you need to tell which instrument you're gonna use. It's gonna give you only the reagent available for this instrument. You can build for target and reagents. So if you want the CD3, they're only gonna give you the CD3 flow reagent that work for your instrument. It support the panel design for BD spectral cytometer, but also other instruments like the Cytek Aurora or the Sony or any custom instrument that you can put manually in there. Yellow remote collaboration on the panel, so you can share your panel with someone else and they can give you advice on what you should put together or not. Also, you can use the OMIPs. So if you don't know OMIPs, what they are a panel that been published. We are currently in OMIP 105 or 106, I believe. So there's 105, 106 flow cytometry panel for different type of characterization of cells. One of the famous one is OMIP 102, which is a 50 color panel that was done and is a full immunophenotyping. And also, we have some BD predefined panel for a specific cell population. So you can just reuse those that's been published, they've been optimized, and they're ready to go if you're using the same type of instrument that the author, or you can just use a part of it or just as an inspiration for your own experiment. The second part is experiment. So in BD Research Cloud, you can create your experiment away from the instrument. So if you're using FaxDiva instrument, or Faxaria, Canto for this Symfony, they're all BD FaxDiva instrument. You can create your FaxDiva experiment away from the instrument. So you can put all your panel information directly into your experiment from your panel design or just enter them manually. You can put your keyword as well there so you don't waste time, and usually times on the instrument cost money. So here, when you're on your computer, you can just put all those information, and you can add all the annotation label just to make sure it's fully labeled. And after when you go on the instrument, you just have to import this experiment on the instrument, and you're ready to go and record your data. The third part is the workflow. So the workflow is just your protocol, lay out all the different tasks that need to be completed. You can be for one person, but it can be distributed to a different person. And every time a task is been done by one person, the next person will be informed that the task is done and it's their turn to do the next task. Data storage. So you can put all your data on a BD Research Cloud. It's easy to share from user to user. It's also integrated with FlowJo, as I'm going to show you in the next few slides. So you can import your data directly from BD Research Cloud into FlowJo, so your FlowJo data doesn't take space on your computer anymore. Cytometer. To design a panel, we need to know your instrument. So you can upload your Cytometer configuration there, or just create your instrument from scratch. To design your panel, but also share your instrument with your coworker if someone has to design a panel or do an experiment on the same instrument. Reagent, you have access to the whole BD catalog of reagent, but also you can create a custom reagent. Population. So most of our competitor ask you when you design a panel to put all the marker that you want. So you have to put, for example, Treg, CD3, CD4, FOXP3, CD127. At BD, we took a different approach. Now you just say you want to define a Treg population, and we're gonna all put the marker directly that are required to define this population. If your population that you want to define is not one. Group and group, you can create group with an organization to share your data and all your information to specific people. You have different type of experiment, so you can share a different type of the experiment to a specific user and specific group of people. And a user is just define who do what and what. So that was the brief teaser on BD Research Cloud. If you want to know more about BD Research Cloud, just go on our website, flowjo.com/learn-webinar, and you have an hour webinar on BD Research Cloud where we give you all the tips and tricks on how to use these fantastic tools. So now let's talk about FlowJo 10.10. So FlowJo 10.10, how to install the software first? Just go on our website, click on the download tab, download, and you're gonna find the latest version of FlowJo. We are currently in FlowJo 10.10. It's available for Mac or PC. If you install it for Mac, you're just gonna click and drag your FlowJo icon to your application folder. If you're on a PC, just follow the installation wizard. Now that we have the software installed, we need to have a license. There's 3 different types of license for FlowJo. First one is a dongle, is a USB key that you put on your computer that gives you access into the software. The second one is a serial number, which is linked to your computer hardware address. Those two, dongle and serial number, are legacy licenses, and we're phasing those away and move all the licenses now to Portal. And Portal is a credential-based license with a username and password. Just need to create an account on cloud.flowjo.com, and after when you have your license created on that, you can just use your username and password on up to 4 computer to have access to FlowJo. So you can use FlowJo on your lab computer, laptop, home computer if your institution allow you to do that, and whatever 4 computer you want it to be. If you never open FlowJo, here's how FlowJo Workspace is organized. So we have 3 different parts. The top part is the ribbon, tab, and band. The middle part is the group and group analysis. And the bottom part is the sample and sample analysis. Let's go in detail in each different part. So the top part, the ribbon, tab, and band. So if you click on any tab, really, this ribbon organization allows easy visualization and navigation through the workspace function. So for example, if I click on the FlowJo tab, I have all the navigate option, all the experiment option, and all of the biology option. If I click on the file or edit, I'm gonna have a different band. And band really group action. They are similar to each other. On top of the tab, you have the taskbar. The taskbar are a shortcut, what we think you're gonna use the most, which are the add sample, create group, composition, your table editor, layout editor, and recalculate. Your FlowJo icon is your application button, mostly to save your analysis. And because we want you to organize FlowJo the way you like, so like that you find your tools and your function the way the organization is more fluid for your analysis, we have different preferences and a configuration here. So the first one is the ribbon configuration. So you can change every function in the band. So if you want to have the Boolean gate in your FlowJo tab instead of a tool tab, you can change that by clicking on ribbon configuration. Preferences in FlowJo, you can change everything and anything. If you don't like the default graph, the default gate, if you don't like the font, you can change that in the preferences. And the last one, the interrogation point, is your documentation link. If you don't know how to do something in FlowJo, just click on this button. It's going to open a web page with a search engine and say, for example, I want to do cell cycling in FlowJo, and we're going to give you article on how to do cell cycling in FlowJo. The middle part is the group and group analysis. In FlowJo, group play the same role as a folder on your computer. So you can create as many group as you want, and you can assign the sample to each different group. A sample, many different group. There's no limitation to that. So you're gonna have as a default the group name, the size of the group, so how many sample you have in each group, and the role for that group. You can also apply an analysis to a specific group. When you apply an analysis to a specific group, like we did here on the master gate group with time, singlet, lymphocyte, live CD3 gate, this analysis takes the same color as the group. Easy for you to know if where this analysis has been applied. The bottom part is the sample and sample analysis. When you select a group, in this part, you're gonna see all the samples that are included into this group. As a default column, you're going to have your sample name, your statistic, which is the percentage of parents, and the number of cells. You can add additional column if you want. Here, for example, I did add my keyword column with my HIV status, patient ID, stimulation, but you can add whatever you want. Next to your sample name, you have three icons. The first icon is your graph windows indicator. Graph windows is where you're going to start drawing your gate. So double click on your sample name or on any gate and your graph window is going to open and you will be able to add the gate. And this diamond is going to become blue. So you know exactly where you're located or which graph you're seeing. The second icon is the circle. The circle is your sample quality check. So depending of the column, it's going to tell you if you had any issue running that sample on the instrument or not. So if it's green or blue, that means you have little flows on your sample. So most likely everything went well on the instrument. If you have any other color, pink, orange, red, that means you had the issue running your sample on the instrument. You probably had air bubble to do some QC before analyzing your data. And the last one is the square icon. Your square icon is your composition indicator. If you have an empty square, that means you have no composition applied to your sample. If you have a grid, like here, that means you have a composition applied to the sample. If that grid is gray, usually that means is a composition that was done on the instrument, what we called acquisition defined. If it's any other color, like here, my orange grid, that means it's a composition that was done in FlowJo. All right, so now that we know the organization of the workspace, I had to add a sample into FlowJo. So you have two ways to do it. Either your data is local on your computer or your data is on BDSC. If your data is local on your computer, you can click on the add sample icon and look for UFCS file on your computer, or you can just click and drag UFCS file directly from your computer to the sample section, or even the full folder included UFCS file from your computer to the sample section. If you click and drag the full folder, this folder is going to become a group with the exact same name that you have for that folder. If your data is in BD Research Cloud, you're going to click on the Add Sample button, Add Sample from BD Research Cloud. You're going to look for your experiment in BD Research Cloud window, and you're going to say Import, and your data will be available to be analyzed. All right, so before we jump to the live demo, let's talk about the data I'm going to use today. Today, we're going to use phosphorylation plus intracellular staining data or PFIX data. The human PBMC, those human PBMCs were stimulated with PMA ionomycins for 2 hours, or they were not. Then we block the protein secretion and with Golgi stop. Then we stand for a variability dye, ARD, and surface antigen, CD3, CD4, CD8, CD38, and HLA-DR. Then we re-stimulate those cells with PMA ionomycins for 20 minutes, or we didn't. We fix with PERM, and we stand for intracellular antigen, phosphorylation ERK1 and 2, interferon gamma, and perforin. So we have two stimulations for combination, double non-stimulated, non-stimulated, stimulated, stimulated, non-stimulated, or double stimulation. We have 5 donors. So with those 4 conditions, that means we have 20 experimental samples. We also did run one donor with a fluorescence -1 control, or FMO. So we have 7 FMOs. If you don't know what FMOs are, they are the true gating control in flow cytometry to know exactly where you put your gate. And of course, we have our 11 composition control or single stain control, which are 9 single stain control plus 2 unstained beads, and unstained cells. All right, let's jump on the software and let's do this analysis. By the way, the chat is always open. Don't hesitate to put your Q&A there. Happy to answer any question live. So I'm going to open FlowJo 10.10. credential. Okay, so I'm logged in. Good. So as I mentioned, if you click on the tab, the band is changing, and you see all the different function in each different tab. So for example, I have my Boolean gate function here in my tool tab. Let's say I'm gonna use that function a lot, so I want to put my Boolean gate function into my FlowJo tab. So how to do that? Just gonna click on my ribbon configuration here, take my Boolean gate function right there, and just click and drag it into my FlowJo tab. And now my Boolean gate function is available here in my FlowJo tab. Still there in my tool tab, but as well here. If I don't want it anymore, just click on the name, click and drag it outside the software, and there you go. Let's go. If you made any mistake, you can always bring it back to manufacturer by clicking apply default. So let's go to the preference now in FlowJo, which is the heart logo. Click on it. So if it's the first time you're turning on FlowJo, I recommend you to go into the workspace. In the workspace, instead of using FCS default as your sample naming, recommend you to use the use short file name file URL. Usually give you a better naming, and that's really depending of the instrument you're using. Some manufacturer doesn't really follow the Flow Cytometry standard file um, recommendation. So to have a better naming, usually use a short file name work better than just the FCS default. Also recommend for you to enable the autosave so that if anything happen during your analysis, if the software crash can happen, if your computer crash, or if IT is pushing you a new update and restarting your computer in the middle of the analysis, you're not losing all your work, but maximum 10 minutes for me. Okay. All right, let's bring the data. I'm gonna bring the data from my BD Research Cloud. So add sample and sample from BD Research Cloud. There you go. All right, so my sample been added. Okay, so I have my composition sample. I have a group that's the name of this experiment, by the way. So let's go in my composition group. You see that he put my composition to me automatically into this group. So let's see I do it. So let's open the preferences of this group by just double clicking on this group name. So it's telling me that the name of this group is composition, the color of this group is red, the style is bold, the role for that group is a composition. This group is a live group. That means any sample that's gonna be added to my workspace, if it match the criteria of this group, will be automatically added to this group. This group is not synchronized. The synchronize option means that if you modify a gate from that group, that gate will be modified for all the sample from that group. We have the panel here. So we have HLR-DR, YRK1 and 2, CD3, perforin, CD38, interferon gamma, CD4, CD8. I have only one panel, so there's no reason to split my sample based on the panel in this case. But if you are running two different type of experiment, that's one way to split your sample based on the panel you're running. And we're looking now to so how FlowJo separate the composition tube from the other. It's just gonna look at the file name that need to contain the word comp, or my file name that contain the word stain. So everything is good. Everything is happy with it, and okay. But what happens if I don't label my composition comp? Maybe you label them control instead of comp. So if it's a one-time thing, you can just change the name and replace this comp by control and click on apply changes. If it's something that you do every time that your instrument labeled the composition control instead of comp, just go in the preferences, go in the composition platform right here, and change the name right here from comp to control. All right, so my internet seems to be really slow today, so sorry about that. I keep getting the message that it's unstable. So we have this group that's the folder where I had all my sample in it. So I don't need that group. So I'm just gonna select that group and click on delete and remove that group. So now I'm gonna create a group for my FMO control, and I'm gonna create a group for my, just gonna bring the data from local. So 11 composition control. Now I have my FMO as well. So my 7 FMO, and I have my 20 LD sample right here. So I want to create a group for my FMO, and I want to create a group for my LD sample. So let's do that. So I'm gonna click on my create group icon, either here in the shortcut or in my FlowJo tab, create group. At my create group window that I open, I can change the name. So this one's gonna be my FMO, change the color, just gonna put green just because. This role is a control. When I leave it on live group, and because they are my FMO control, I want that gate to be applied to all my sample. So I'm gonna check my box synchronize. And here you see that all my FMO are labeled FMO something. So I'm just gonna tell FlowJo that to look for my file name that need to contain the word FMO. And any sample that have the word FMO in it is gonna be added automatically to this group. And there you go, I have my FMO group with all my FMO in it. You look for my LD sample, all my LD sample are labeled LD something. So I can do the same. I can create group. This one is my LD sample. Bold and italic. I'm not gonna synchronize my gate for those. I want to be able to adjust my forward scatter, side scatter for each individual sample. And I'm just gonna look at my file name to contain the word LD. I can do that. If I click on create group, my 20 sample will be added to this group. No issue. But maybe your samples are not, don't have the same character, so you cannot do that. So another way to do it, to make it a little bit more challenging for the training, we're just gonna say that my LD sample are everything but my FMO and my composition. So I'm still gonna use my file URL, but since the word FMO, and I'm gonna click on more choices, and my file URL is lacking the word comp. So they're not my comp, and they're not my FMO. All right, so now you see that all my LD sample has been created and have been added to my LD sample group. All my FMO are in my FMO group, and my composition before I start directly to the analysis, I just want to make sure that my first label enter correct. Seems like I'm back. Sorry about that. Got my internet disconnected for a second. Okay. So we were on here's go and edit column. And here you have the list of all the keywords. Most of those keywords are keyword about instrument configuration. So the type of laser that you have, the type of how many detector you have for each laser, when's the last time you ran the baseline, when's the last time you ran the QC, but also you have all the fluorescence information as well. So I'm just gonna select all those fluorescence information and I'm gonna add those as a column. And we can make sure that the label have been put correctly on the instrument. And you can see that it's been done correctly, that the label CD8 is on my back blue, the label CD4 is on my P Texas red, and interferon gamma on P Sci7, etc., etc. So if you mislabel one of your flow crown, that's why you can change it here in FlowJo. For example, if I go on all my sample, you see that my live dead marker is not labeled on all my sample. It's only labeled on my regular sample, not on my control. So if I want to label it for all my sample, I can just click here on one specific tube, label it. Just gonna call it live dead, so that is different than just the other one. And if I want to apply this live dead keyword to all my sample, I just go into my workspace in the keyword and click on copy this value to group. And now my ARD is labeled correctly, so I can go back to my edit and I can remove all those. I don't need them. So now I can look in the list of keyword and I can look if I did any keyword that may be useful for my analysis. And personally, when I add keyword, I always put a star before the keyword, so I know those are mine, the one I added manually on my acquisition software. And if you look at those keywords, one is condition, one is d-date, d-date which in this case was the same patient ID, my stimulation, and my t-date. T-date was the date I ran the sample on the instrument. So really the two keywords that are needed for this analysis are my stimulation and my patient ID. So I'm just gonna select those two keywords and add them as a new column and click OK. So my LD sample, you can see my sample name, the statistic, frequency of parents, and my keyword. So I can double click on any, and I'm just gonna organize them based on my sample name. So now we want to do the analysis. Now that the annotation is done, so we're just gonna double click on any sample name. By the way, I don't need to do the composition. The composition was done on the instrument. You see that my square here has a grid telling me that the composition was done. If I put my mouse over, say the composition matrix is acquisition defined, so been done on the instrument. If I want to visualize this composition, I can just double click and I can visualize the composition matrix. So here's my composition matrix. The cyan is before composition, the black is after composition. If I don't want to see that overlay, I can remove and see only what's after the composition. And I can check on specific sample if my composition looks good or not. And looks good in Cytometry for composition just mean that your composition is square. And my composition looks fine, so I can keep going on my analysis here. If you want to redo your composition, you can do that in FlowJo. We have a talk, an hour talk on our website. Just go in the FlowJo.com and the webinar, the same place where you register for today, and go at the bottom, the recorded webinar, click on it, and you're gonna find the previous presentation that we've done on composition. All right, so here we're gonna open my LD14 sample. So I'm just gonna double click on my sample name, is opening my graph window. See that the diamond now is on my LD14 sample, telling me exactly which sample is open. Also have the name on top of my graph windows telling me which sample is open. With the arrow here, I can go from sample to sample. Okay. You see the diamond is moving, the name here on top is changing. So let's go back to my LD14. You have your getting tools here on top left. So a rectangular, quadrant, elliptical, polygonal. Every time you click on, you make an angle. Hand drawing tools, tool taking in consideration the density. So try to follow the density of your sample. And the last one, the last two are specific quadrant gate. The first one is quadrant gate taking in consideration the spread of your data. And the last one is called a spider gate, where you can change the center of your quadrant, but also where your axis are starting. You can change the axis. So right now we're visualizing forward scalar, side scalar. That's what we want. If we don't want that, click on the axis, select which parameter you want to display. We have our T button here, which is to change our transformation. So do you want linear, log, or customize it? And I will leave it on linear for forward scalar, side scalar. And after you have the different option. Right now we're visualizing the data in a pseudo color plot, but you have different other type of plot like a contour plot, density plot, zebra, pseudo color. So contour plot, if the circle is small, if you're hiking, you know that if you the circle is small, that means you're gonna go up the mountain. That means you have more cells here when the circle is small than when the circle are big. Density is the black and white. Based on the density, black, a lot of cells, white, less cells. Zebra is a combination between contour plot and density. Pseudo-color is every cell is a blue dot. If there's already a cell with the exact same value, your blue dot's gonna change color from blue all the way to red based on the density. Dot plot is just every cell is a black dot or whatever color you decide the dot to be, and it's not gonna change based on the density. And histogram is your fluorescence intensity versus number of cells. So I'm just gonna use the pseudo-color, like the pseudo-color plot. That's what I'm gonna use for the analysis. So let's select the cells first. I'm just gonna propagate one population of interest, which are those, and cells. You see that I have a active gate option here. So if I click on it, I can select the event inside that gate. That's what I want, or the event outside. I can create a magnetic gate who's gonna try to follow the density of this population. And I can also tint my gate. If I want to change kind of the size of this gate, I have my plus or minus button that keep the same shape of the gate, but increase or decrease the size of that gate. All right, so I'm gonna gate around my cells of interest. That gate is good. Can double click on it. You see that it created a cell population under my LD14 population, and is on this cell population. So now I can do a doublet discrimination gate of forward scalar A versus H. and select only the singlet. Okay, so make sure you take only what's in the diagonal. There you go, which is 99.5% of my singlet gate. You can double click on it, and now I have only the single. My diamond is only on the singlet. So now we can select another population, or another parameter, sorry. So let's go with CD3 versus forgot the live dead versus let's do size scaler and only select the live cells. Live. And now let's go for CD3 versus HLR-DR. There you go. I can draw run-on gate, rectangular gate. I see three population. I'm not interested in the DR population, but just to show you, based on the density, I can really select the DR population here by just following the density. You see that I'm missing some cells right there because the density didn't select everything. Don't worry, I can use the plus and minus to increase that population and make sure I select everything. So now let's select my CD3 population and let's look at my CD4, CD8. Draw a gradient. Can rename those quadrants. So my quadrant 1, which is on the top left, is my CD8 positive. So just call it CD8. This one is my double positive. This one is my CD4. And this one is my double negative. Right? Now I'm gonna go on my CD8 population. So double click on my CD8 quadrant, only select my CD8. And now I can start looking at my cytokine. So I can look at interferon gamma versus size scalar and only select what's interferon gamma positive. And when it's not the real FMO, will really tell me where to cut. But I just want to draw this gate on this sample just to have a general idea where to put my gate. So this one on perforin and the last one on ERK1 and 2. Okay. So now that I have my gate for my CD8, this cytokine expressed, especially interferon gamma and ERK1 and 2, I also express on my CD4. So I can select those two and click and drag those population on my CD4 population. And now my interferon gamma gate and ERK1 and 2 gate on my CD4. So if I open my CD4 population and look for my ERK1 and 2 versus scalar, I can see my ERK1 and 2 on my CD4. So that's good, but if I change the gate on my CD8, see that it doesn't change on my CD4 automatically. If you want those two gates to be linked together, you can clone those gates. And the way you do it, you just select your interferon gamma gate, right click on clone gate. Now you have the three dots telling you that the interferon gamma is ready and is cloned. And now you can just click and drag this to my CD4 population. Internet is really unstable. I hope everybody can hear me okay. Like a pair as does the sharing. Let me share again my screen. All right. All right. So clone gate on my CD8, and now I have the 3 dot telling clone. I can click and drag that on my CD4, and there you go. Now they clone. So they both have there on my CD8 and CD4. So now if I open my CD4, ERK1 and 2, and my CD8, ERK1 on the other one is moving the exact same way. Right, so when I was a grad student and was doing this experiment, my PI used to ask me, is it one cell producing all those cytokines from my CD8, or is it different CD8 that produces each one cytokine? So to answer this question, you can do it instead of doing many manual gates to have the answer. You can do it in few clicks, sorry, using the combination Boolean gate. So let's go in my tool tab, Boolean gate. I select my 3 cytokine right there, and I click on create combination gate. Gonna say it's gonna create combination gate for those 3 gate, and my other one, click OK. Telling me which cells are single positive for every side or negative. So the triple positive for interferon gamma line, that means 11 cells are triple positive for those after have every other combination. Analysis, I can select this analysis and click and drag it to my FM. On my FMO, as I mentioned, my FMO, I'm a true gating control. So really, that's on my FMO that I'm gonna really be able to put my gate at the right place. So we see that my first FMO is no CD4. That means I put everything in my tube except my CD4 antibody. If I go on my CD3, I should have no staining for my CD4. So it's really going to allow me to put my vertical gate as close as possible to my negative population. And if on any other sample I see a shift and things that as that vertical gate, that means it's real positive for CD4. So as you can see on my CD4 population here, I have few dots. This sample I've been running plate, you can see that D12, that's the number of my well, and add some carryover between each well. So was not washing well enough between each sample. I was a grad student at that time, but that's the reason there. So we're just gonna ignore those few dots here. So let's now adjust my vertical gate, try to put it as close as possible to my negative to not having too much there, something like that. My gates, remember in my FMO group, are synchronized. That means if I move my gate crazy, it doesn't matter. If I go on my next tube, you see that my gates stay exactly at the same place. So let's put it in the right place. Go to the next tube. My next tube is no CD8, which is going to allow me to put my horizontal gate. So here I can go down a little bit. There we go. Then we go on my next tube, no HLR-DR, so I can go up in my analysis and make sure my HLR-DR gate is correct. Then go to my next, which is no interferon gamma. So we can go on my CD8, show interferon gamma. No interferon gamma, there you go, and adjust my gate to take almost everything. Yeah, etc., etc. And at the end, make sure that all my gates are at the right place per frame. And so now that are good, I want to close all my graph window. Close all my graph windows in one. I can just go in the file, close all graph windows or learn the shortcut, which on Mac is the Apple key, Shift and W. On PC, you will find this file function here on top of any graph windows, just cut, and that's mentioned there as well. All right. So now that my analysis is done on my FMO, I can copy this analysis on my actual sample. Click and drag this analysis on my LD sample. Remember, my LD sample is not synchronized. That means if I adjust my forward scalar, side scalar gate, which are the only gate now I can adjust, it will only be specific to that sample. So if I move it for this LD1 double non-simulated, if I go on my LD1 with one simulation, you see that it goes back to default. FlowJo even tell me that this one is specific to the sample. You see it doesn't have the blue color anymore, but it has the black color telling that gate is specific to this sample. If I want to bring it back to default, just select it, click delete. You should want to delete this population. Yes, bring it back to the blue color and to the default from the group. They also show you that you cannot delete a population that's applied to a group. Okay, if you want to delete a population that's applied to a group, you will need to go in the group section and delete that population here. So if I want to delete my CD3 gate, for example, I need to go in my FMO group, select my CD3 within my FMO, click delete, and I can choose whatever I want, set delete entirely. So for all my FMO sample, my CD3 gate will be deleted. All right, so I can double check that my forward scalar side scalar gate is good for all my sample by clicking on the next button. So go right arrow, there you go. Everything is good. Select my forward scalar side scalar correctly. So my analysis is done. Now I want to export this analysis. You have two ways to export this analysis, either the graphical export with the layout editor, or the statistical export with the table editor. So let's start with the graphical export with the layout editor. So I'm just going to click on the layout editor. You can go also in FlowJo, navigate layout editor, same thing. And it's going to open your layout editor window. So to display my population into the layout editor, I'm just going to select my population of interest here. So let's say I'm interested in my CD4 population, and I'm just going to click and drag my CD4 population from my workspace to my layout editor. And there you go. I have my CD4 population right here. The layout editor is organized the same way as your workspace. So you have different tab and band. So explore all those functions. I'm not going to talk about all of them today. Same thing can be customized by clicking on the ribbon configuration. So right now I'm displaying my CD4 population right here. Okay, and I display my ERK1 and 2 gate. Probably not what I want to show, so I can double click on it. And let's say I want to show my interphone gamma gate. So I can change my X axis and put interphone gamma. I still want size scalar in the Y axis. I still want a pseudo color, that's fine, but I can do some smoothing. I can show the outliers to make sure I can see that there's a few dots into my gate. I can use large dot if it's a really rare population and to make sure that people can see it. And I can show grid if I'm doing a presentation and I want to make sure that people in the of my interphone gamma. Different option there based on the type of graph you're using. You can annotate your graph. The annotation is right here at the bottom. So here is telling you your sample name, which population you visualize, number of cells. If you don't want to show it, you can remove it. I want to do it. You want to show the gate? Yes. Do you want to show the frequency and population name? Probably not in this case. You want to show the axis? Of course, you can rename your axis if you don't want to see comp Psi7 interphone gamma and you just want to see interphone gamma. You can just type it here and say scalar. And there you go. You have your axis label change. You can adjunct histogram if you want. But most importantly, I think in this option is to show the ancestry. Ancestry is gonna show your getting strategy that you've done to define this population. So by just clicking this box, it's showing me that I did a 4-scalar side scalar, double discrimination, live, CD3, CD4, and display the CD4 right here. So I don't have to click and drag every single population, just drag the last one and click on the ancestry and it will show all your getting strategy. By default is vertical. If you don't want vertical, you can have it horizontal by clicking on that box. Also, FlowJo has a true backgating. So it's gonna gate on the last population you display. So right now CD4, and it's gonna show you if you apply this CD4 gate on all your events, where those events will fall. And you see that most events fall in my 4-scalar side scalar at the right place, the blood discrimination. You see some CD4 positive in my live dead marker, but the cells they can die, and you can see some CD4 positive in my HLRDR positive, CD3 negative. Well, we know that CD4 can be expressed in monocyte granulocytes, so nothing to worry here. Font, if you want those graphs to be published, some journal require specific font, specific size. That's why you can change it. And legend is mostly for overlay. We're gonna, if we have time, we're gonna talk about it. All right, so I have my graph, I have my page. You see with the dot, that's my page 1, page 2, 3, 4. So I can go in my file and I scale, for example, that one page so that I don't have page break in the middle. You can also put your mouse over in the corner of the page and you can decide if you want landscape, portrait, and change the size of it. When you're happy with your analysis and you want to apply this analysis or this report for all your sample, that's where you're gonna batch. So creating a batch is basically applying the same graphical export to every single sample from your analysis. And you can decide for all of them or for a subgroup of it. So now I want this report to be only on my LD sample. So I make sure that in my group, I select only LD sample. I can even be tighter on for which sample I want that report to be. So you can use keyword, for example. So my STEAM keyword or my LD1 patient ID keyword, I can be used to create a report only on specific sample and not all of them. But today, in this experiment, I want to have it for all of them. So I'm just gonna turn off this iteration. So really what I want to do is have 20 sample. I have 4 condition, 5 type of specimen. So I want each column to be one condition and each row to be one specimen. So when FlowJo create those report, it's just gonna follow the order of your sample that you have into your workspace. So if you remember my workspace, just gonna compress that, collapse all. There you go. See that my sample are organized by based on my LD number. So all my LD1 first, then all my LD2, then all my LD4, 12, 14. And after is based on my stimulation. So if I want each row to be one sample, I need to go across column. So I'm gonna create 4 column because I have 4 condition. I'm gonna go across column and I'm gonna separate page to make sure I don't have a page break in the middle. I can create a new layout or I can directly send it to the printer, web page, PowerPoint, PDF. I'm just gonna do it a new layout and I always recommend you to do that first. I click on create batch. There, a batch has been created and see that my first one is my LD1 double non-simulated. Then I go to my next one, LD1 one simulation, the other LD1, the other simulation, and my LD1 double simulation. And now if I go by column, you see that I should have my LD2 double simulated, yes. Go down, LD4 double simulated, etc., etc. So really the organization is what I wanted. So right now I have one page per condition. That's the way I want. I can go in File, export image, and put it in whatever format I want. If I want to put all those into one page, I can just take the batch break and move it to one page, or click on Scale to Page, and there I go. Now I can export this and report in only one page. Maybe not the best way to analyze the data. Maybe I want to create overlay the 4 condition into one graph. So I'm gonna create a new layout by clicking on this plus sign. Okay. Now I'm gonna take again my CD4 population. But now I'm gonna go for the other condition. I'm gonna take my CD4 population again, and I'm gonna put this CD4 population on top of the other one. You see the square becoming blue. That means I'm gonna overlay those 2 conditions. Go. Same thing for my third condition. And the double simulated condition, we're just gonna put on a miss. Don't worry, you can always click and drag back on top of it. And there you go, the overlay. So here I have the overlay of my 4 condition. I have my legend here. In my legend, I see the color. I can change the color for whatever I want. I can even right click on it to change the property of each graph. So let's put it as a histogram first. Histogram, apply. And here I can change, for example, on my histogram, the color, filling, the line style, the weight of the line. If I want my histogram to be at the same height for each sample, instead of having the y-axis in auto, I can use the y-axis in mode, and the graph line will be at the same height in all of them. I can change the order of the overlay by just clicking and dragging to organize them the way I want. I can right click also on my graph, go in histogram, and instead of having an overlay, I can do a half offset, or I can do right click, not double click, or I can do the full offset, or can be nice for presentation is the stagger offset. Okay, stagger offset, you can change the angle by clicking on the blue square. Okay, so if I want to put my controller all the way to the back, I can just do it like that, or the other way, all the way to the back. Okay. All right, I'm happy with this overlay. I can double click on it. Can change, of course, the axis again. Just put here K1 and 2. Apply. And in my legend here, that's the information that's going to be there underneath. So we have a sample name, subset name, and number of cells. Okay, that's what it says. Maybe I don't want the number of cells, so I can remove that to add some stats. So maybe I want to add my MFI of ERK1 and 2. In this case, add. Okay. And maybe I want to add my keyword. If I click on the key, I can look at my keyword stimulation. Okay, and apply. And I have my MFI and my Steam keyword right here. All right, I'm happy with this report. So now I can batch it for all my sample. So, but if I look at my layout, you see the batch button is grayed out because I cannot batch it. But the reason you cannot batch it is because you overlay 4 different samples on top of each other, but to FlowJo, they don't really know what they are. So you need to give a rule for FlowJo to be able to do it. So If you have one, you just overlay two samples, and one is always going to be a control, and you always want that control to be there. For example, if you're doing a GFP experiment and you always want to have your white type overlay with your actual sample, you can just select that universal control, right click on it, and click on set as control. Not gonna work today. So the way we do today, and we have two ways to do it today, is either say, take the first 4 samples. We saw that our first sample are my LD1, then overlay my next 4, which is gonna be my LD2, then overlay the next 4, which is gonna be my LD4. So that's one way to do it. And you can just say iterate by panel and take the first 4, then the next 4, then the next 4. So if I click on create batch, it will work. Another way to do it is to iterate by keyword. You select the keyword and you can say what consistent is my patient ID, and what can change, is my Steam. And click OK. And now I can create my batch as well. Okay. And if you check, you see that my first batch is my D1, the next one, my next overlay is my D2, my third overlay LD4, etc., etc. So exactly. All right, so let's go to my table editor here. This grid of FlowJo table editor. Here's to export my stat. Select the population that you want your stat on. So for example, my CD4, you can drag my CD4. It's a frequency of parent. If it's not what I want, I can just double click and select whatever stats I want to display. MFI of interferon gamma. Okay. And keep doing that. When you create a table in FlowJo, so each row here in your table editor is going to be a column on your table that you're creating, and each sample is going to be a row. So you can add as many as you want. So let's do that again for ERK1 and 2. ERK1 and 2. So that's one way to do it. I'm doing it right now. So click and drag the population. Another way to do it, which I usually like better, is to click on your workspace, statistic, and here I want my MFI. So I can click a median fluorescence intensity. I can select for which parameter. If I have multiple, I can say choose multiple parameter. And here I'm gonna select interferon gamma per frame, ERK1 and 2. Okay, and I did create my stats right there. I can copy this analysis to the group and click and drag my stat on my table editor. I can always add additional columns. So let's add, for example, a keyword column with a Steam. Okay. And I'm gonna put this Steam keyword column between my CD4 and CD8. So I just need to put it in column number 3. I can just click and drag on column number 3 and it's gonna replace that. And I want my cytokine expression to be in the same order on my CD4 than my CD8. So it's interferon gamma, ERK1 and 2, ERK1 and 2 performing interferon gamma. So I need to have this interferon gamma on column number 3. And there we go, interferon gamma, ERK1 and 2 perforing. And now I can create my table. Okay, it's going to create my table on all my LD samples. Same thing, you can choose if you want to create a report only on sample with a specific keyword. Here, I will do it on all of them. You can display this table or directly send it to printer, file, layout, or clipboard. Let's just display. And there I have the table of all my stats. So I have all my samples here. Each row is a sample, each column is one of my stats. I have my Steam keyword. I can organize my sample based on that keyword, for example, and see all the value. So if I ask you, did the stimulation work or not? Well, human eye is not really well fitted at looking at a number. So we realize that FlowJo, so we have a visualize tab here. By the way, your table editor organized the same way as your workspace and layout editor. So if you click on the visualize tab, you have more option, and you see that we have this heat map function. So I'm gonna select my stat, click on the heat map, And now when I display my table, you see that my number are color coded. Okay? Yellow if it's really positive, blue if they're negative. So now I can organize my sample based on my condition. And you see that my MFI worked for my ERK 1 and 2 on my CD4 and CD8. As soon as I have a stimulation, it's becoming yellow. But if you look at my interferon gamma or perforin, I don't really have like a nice trend like I do for my ERK 1 and 2. So it seems like it didn't work. All right, so now that my table is created, I can just save as Excel, text, CSV, or whatever format I want that table to be exported. Maybe I want to put that table on my layout. So where I did on my overlay. So I'm just gonna say, save this table on my current layout, create table. There's gonna be a picture of that table. Yes, it's fine. And there you go, I have my table on my layout editor. In the layout editor, you can adjust it to, let's say, landscape. You have all those text, shape, or whatever that you can do really to create a nice report for this data set. All right, so we're done with the analysis. Let's talk a little bit about the different way you can save this analysis. So we're gonna go and save as. So you can save as a workspace. Save as a workspace is a recommended way to save your analysis while you're still working on it. When we click and drag the sample into FlowJo, what you really do basically is tell FlowJo where your FCS file is located. So um, FlowJo will never have the FCS file inside FlowJo. It's just gonna pin your FCS file to get the information is required to show your graph and calculate your stat, which is the reason you don't really need a powerful computer to analyze your data, even if you have million and million of cells and hundred of sample. So when you save as a workspace, basically you FlowJo just save your analysis, your layout editor, your table editor, and the path to find your FCS file. So great when you're still analyzing your data. The issue with saving as a workspace is that if you try to share your analysis with someone else, or if you move your FCS file to a different location, but FlowJo will lose the connection to your FCS file because that path will change. So you're gonna have to either tell FlowJo where you put your FCS file, or FlowJo just gonna start scanning your computer to try to find your FCS file for you. So really not the best way to save your data if the intention is just to store it for long-term storage, or if your intention is to share it or send it to a collaborator or your boss or whatever for them to look at your data. If that's your case, it's recommended to save as an archive. When you save as an archive, you're gonna save your FlowJo analysis, but also your FCS file in one big package, and that .scs file can be shared with anyone, and you're never gonna lose that connection. And that'll show you that you have BD Research Cloud, where you have your FCS files on the cloud, so you can you don't have to have your data local anymore. If you save your workspace in the BD Research Cloud, you can share this analysis with your collaborator, your boss, or whatever. And of course, you're never gonna lose the connection because it's always gonna be in your BD Research Cloud. And the last one is save as a template. In flow cytometry, usually we run over and over the same experiment. Instead of starting from scratch in your analysis, you can use a template. That's what we're gonna do now. I'm just gonna save it as training template on my desktop. There you go. Here. And if I close this one, save it, doesn't matter. I'm opening my template. So we are next day, a week, a month, a year from now. I'm running the same type of experiment, and I need to analyze it the exact same way. I open my template. You see that FlowJo save your analysis, but didn't save your path for your FCS file, and it's just waiting for you to dump a new FCS file. So I'm just gonna look for new data here, immunophenotyping, select a new set of data. So it was just a repeat of this previous experiment. Click and drag my FCS file now in FlowJo. And because my group live, FlowJo automatically put the sample to the right group. You have my 7FMO in it, my 20 LD sample into my LD sample group, my 11 composition in my 11 composition. If I go in my layout, I see that my layout will just say there's no population. Don't worry, don't delete it. And the reason it said no population is because your path was not the same, or your sample name was not the same. So you just have to tell FlowJo, take the first sample into my group on my workspace and display the graph. So we click on iterate by sample, and now it's displaying your graph. Also, it's a nice way to overview to make sure that your gate is still at the same place and nothing changed. So you can use those arrow up and down to go from sample to sample to check if everything still looks good based on your getting. If you're happy with it, that's where now you can patch. And there you go. You got your report. Go to the layout of the number 2, which was our overlay. Everything is good. Here, nothing changed in this case, and we can create our batch right away. Then we can go to a table. Table, same thing. We have all the stats. I want to display this table, not to do it in the report. So create table, and I got my table. And I redid my analysis in 3 clicks or 5 clicks instead of the hour I spent with you doing it. I see a question in the chat. Will save the template work with Workspace with HG analysis? So if you talk about plugins, so for example, if you did run FlowAI anything, yes, it's gonna save the fact that you run FlowAI. You're just gonna have to tell it to run it again. Or Tisney, UMAP, you're gonna have to rerun it because every time you run those type of algorithm, is the first step, the seeding step is different. Those on the concatenated file, so not on individual file. Okay. And with that, that's the end of my talk. Happy to answer any other questions. Put back my camera now that internet might be a little bit more stable. I know that you're gonna have a recording of this presentation on our website, so the same place as you register, but if you go down that page, you say recording webinar. So in the next few days, this presentation will be there with all the other one. Well, thank you. All right, if there's no more question, thank you for your time. And you have my email address. If you have any question, don't hesitate to reach out to me. And see you next time.